If we have the graph of the first derivative of a function, we can surprisingly tell a lot about the graph of the original function without having a formula at all. So let's look at this example. There is our graph of f prime. So let's see if we can answer these questions. Where is the graph of f increasing? Well, the graph of f is increasing wherever the graph of f prime is above the x-axis. And it's going to be above the x-axis on this part here, and then on that part there. So it's above the x-axis when my x value, so the graph of f is going to be increasing whenever the graph of f prime is above the x-axis. So this happens when, let me do it in black. When x is between -2 and +2, so that's an interval, not a point. And whenever x is between 4 and 5. So again, that's an open interval there, not a point. So the graph of f will be increasing whenever the x values are in between -2 and +2, and strictly between 4 and 5. It will be increasing. Okay, now let's answer the next question. Where is the graph of f decreasing? Well, the graph of f is decreasing wherever the graph of f prime is below the x-axis. So it's going to be below the x-axis in these portions. Okay, so I'm just going to make that a bit thicker. This is where it's below. Now, where does that happen? That happens when my x values are between -5 and -2, and when the x values are between +2 and +4. So even though I don't have the graph of f in front of me, I can tell you where it's decreasing. Now, does the graph of f have any extrema, any local minimums or maximums? Okay, well, local mins and local maximums happen when the graph of f prime crosses the x-axis. And we can see here that it crosses the x-axis at x equals -2, and at x equals 2, and at x equals 4. So at x equals -2, the graph of f prime is below the x-axis just to the left. So the graph of f is decreasing. Then at x equals -2, the graph of f prime just to the right of -2 is above the x-axis, so the graph of f is increasing. And so we're going to have a local minimum there. So a local min at x equals 2. At x equals -2. Okay. Now what happens at x equals 2? At x equals 2, the graph of f prime just to the left of 2 is above the x-axis, so the graph of f is increasing just to the left of x equals 2. The graph of f prime is below the x-axis just to the right of 2, and so the graph of f is decreasing just to the right of 2. And so at x equals 2, we're going to have this top of the hill a local max. A local max. And then finally, at x equals 4, what is happening? Well, the graph of f prime is just below the x-axis to the left of x equals 4. So the graph of f is decreasing just to the left of x equals 4 on the graph of f. Now to the right of x equals 4 on the graph of the derivative, it is above the x-axis, so on the graph of f it is increasing just to the right of x equals 4. And so we're going to have this bottom of the valley occur, and we get a local min. at x equals 4 on the graph of f. Okay. Now, where is it concave up? Concave up means it's smiling. Okay. So it's concave up when the graph of f prime is rising. Now, where does that happen? Well, as I'm moving left to right, and traveling left to right, I am rising, going upward when I'm on this part of the graph of f prime, and then when I'm also on this part of the graph of f prime. So the graph of f will be concave up when x is, on this green portion, x is between -5 and 0, but also when x will be between 3 and 5. That's where it's concave up. Now, where is the graph of f concave down? Concave down is a frown on the graph of f. So how can I tell that from the derivative? It will be concave down when the graph of the derivative is falling or decreasing. So when I'm moving from left to right on the graph of f prime, we are falling or decreasing on this section of the graph. Now, where does that happen? So f is concave down when the x values are between 0 and 3. Finally, will f have any inflection points? Inflection point happens where the concavity changes. So, the concavity changes at 0. We are concave up when x is between -5 and 0, and then we're concave down when x is between 0 and 3. And so the concavity changes at x equals 0. So we will have an inflection point on the graph of f at x equals 0. I don't know the y-coordinate of that, but I can tell you, you will have an inflection point on the graph of f when x is equal to 0. Now also, when my x values on the graph of f are between 3 and 5, we are concave up. And so once again, the concavity changes, and once again, I have an inflection point where the concavity changes, so I have another inflection point at x equals 3. Okay, so I hope that this example helped. This particular example is when you're starting out and given the graph of the first derivative of f prime, and you're asked all of these things about f. We can't give any specific points because we don't have formulas to get the y values, but we can make these definite observations about what our x values are in each of these questions. I hope this has helped. Thanks for watching. I'll see you on my other videos.